In the ligand sampling section, we have the options to choose whether ligands are docked flexibly or rigidly, refined in place, or simply scored in place. The default is for flexible docking, where conformation generation is limited to variations around acyclic torsion bonds and pyramidal nitrogen inversions, such as in amines and sulfonamides. On by default is the option to sample inversion at pyramidal nitrogen atoms, as well as to sample ring conformations, where only low-energy conformations are kept. Here, you can choose to include the original ring conformation. Here, we have the option to buy sampling of the torsion around bonds that normally adopt a particular conformation, for example, amides and esters. And these options cover different selections of functional groups. So the first option would bias the torsion sampling for a set of functional groups that is defined in a resource file. More info can be found in the Glide user manual. The second option will bias the sampling of torsions around the carbon-nitrogen bond of amides only, and where you can penalize non-planar conformations, which will apply penalties to amide bonds that are not cis or trans rather than freezing them entirely, retain original conformations, which will fix amide bonds in their input conformation, or all trans conformation only, which will enforce the trans conformation to within a small angle range, about 20 degrees. Ligands that do not dock in a transformation are rejected. Here, we'll leave it on the default settings, which is to simply penalize non-planar amide bond conformations. Of course, there is also the None option, which will not apply any biasing, but instead allow the conformation to be determined by the conformation generated via the force field. The rigid docking option does not generate conformations of the input ligand, but only allows the input conformation of the ligand to be translated and rigidly rotated relative to the binding site. This may be useful if you generated ligand conformers outside of Glide, such as in Macromodel, which unlike Glide does not have a rotatable bond sampling limit. There are also two options for not performing any sampling at all. These options are not substitutes for a full docking calculation, and both require accurate initial placement of the ligand with respect to the receptor. The refine-only option uses the input ligand coordinates to perform an optimization of the ligand structure in the field of the receptor, and then the ligand is scored. The goal of this method is to find the best scoring pose that is geometrically similar to the input pose. If you're using HTVS or SP, a minimization is performed, or for XP, the ligand is regrown in place. The score in place option similarly does not perform docking, but uses the input ligand coordination position for scoring. This option is useful to score the native ligand in its co-crystallized or modeled position, or as a post-processing step on Glide-generated poses to obtain individual components of the Glide score prediction of the binding affinity. It can also be used to check whether the scores of the known binders in their native proteins are similar enough to the scores when cross-docked to the chosen receptor. And if this is the case, it is reasonable to expect that similar structures would also score well. Keep in mind, scoring in place should not be used with Glide XP, as full XP sampling is normally needed to avoid strong XP penalties for ligands that should be able to dock correctly.